students, this is Sujata coming with class 10 NCRT SSC Math with Sujata ji. Welcome students in our channel and welcome in the new topic similarity and right angle triangle student. So what is the statement of this theorem student? So let us see the statement of this theorem. In a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. Okay, so see here student, there is a triangle, right angle triangle ABC, and if you draw the altitude, that is the BD is the altitude, BD perpendicular to the AC, AC is the hypotenuse. So if you draw the altitude to the hypotenuse, then there are the two triangles. Two triangles are formed students, and these two triangles are similar to each other, and these two triangles are similar to the original one of the triangle. So let given is in triangle ABC, angle ABC is equal to 90 degrees students. Angle ABC is equal to 90 degree, segment BD perpendicular segment AC and ADC are collinear. Okay, now here to prove triangle ADB similar to triangle ABC, second one triangle BDC similar to triangle ABC, and the third triangle ADB similar to triangle BDC. Okay students, now let us see the proof. How can we prove out this theorem? First part, let us consider, that is the first part, for the in triangle ADB and triangle ABC. So this one triangle, first one new form triangle, and the original one ABC triangle. Okay, so here in this triangle, first constituent is angle DAB is equal to angle BAC. Okay, because this A angle is in both the triangles. Okay, so it is a common angle and they are congruent to each other. Now the second, that is angle ADB is equal to angle ABC, because this angle is 90 degree and as well as this angle is also 90 degree. So these two angles are congruent to each other, and therefore we can say that triangle ADB similar to triangle ABC by AA test, Okay, so now this one first proof is over, first part is over of the proof. Now the second part, consider this one as a second part. Now there is a second one triangle, new second one triangle, and this one, that is the BDC. So let us consider that in triangle BDC and ABC, ABC is the original one triangle. So here in these two triangle, first constituent is angle BCD is equal to angle ACD, because both the angles are common angle. Okay, second one angle BDC is equal to angle ABC, because each angle is 90 degree. Okay, so now we have the two angles, so therefore we can say that triangle BDC is similar to triangle ABC and by AA test. Okay, so now see here, this one is the first part, this is the first equation, this is the second equation, and in both equations that the new one triangles are similar to the original one triangle. So that's why we can say that these new one triangles are similar to each other. So that means triangle ADB similar to triangle BDC, and from first and second. Okay, from first and second, and call this triangle, call this equation as a third one. So from 1, 2 and 3 we have triangle ADB similar to triangle BDC is similar to triangle ABC. Okay, and this is the transitivity property of the similar triangle. Okay. See the theorem of geometric mean students. In a right angle triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the segments into which the hypotenuse is divided. Okay students, now here see that here is a right angle triangle. So we draw the triangle PQR as a right angle triangle. Okay, where angle Q is 90 degrees. So here right angle triangle. And the perpendicular drawn to the hypotenuse. So QS perpendicular to PR. Okay, QS is the altitude and which is drawn on the hypotenuse PR students. Okay, so now here from the opposite vertex is the geometric mean of the segment. That means that QS is called the geometric mean of the segment PS and the RS. Okay students, QS is the geometric mean of PS and RS. Okay, that we have to prove here. Okay, so that's why we write here that proof in right angle triangle PQR segment QS, here segment QS perpendicular hypotenuse PR. Okay, then second, in triangle, here we know that triangle QSR similar to triangle PSR. Triangle QSR is similar to triangle QSP students. Okay, because these two triangles are the similar triangle because these are the right angle triangle. So similar triangle QSR is similar to triangle PSQ. By the similarity of right angles, then we can say the ratio of the corresponding sides are equal. So that means QS upon PS is equal to SR upon SQ. So here QS upon PS is equal to SR upon QS. Okay, that means cross multiplication QS into QS, that is QS square is equal to PS multiplied by SR. Okay, so that means here QS is the geometric mean of the PS and the RS. Okay, the Pythagoras theorem students, we know that what is the statement of the Pythagoras theorem. Okay, so in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of remaining two sides. Okay, then here to prove the Pythagoras theorem as per the given statement, so we draw the figure here as triangle ABC. Okay, we draw the figure triangle ABC here students. Okay, ABC, which is the right angle triangle students. Okay, this is the right angle triangle. Now here in triangle ABC, here in triangle ABC, angle ABC is equal to 90 degree. Okay, angle ABC is equal to 90 degree students, and we have to prove that AC square is equal to AB square plus BC square. Okay students, so now here there is only one figure of the right angle triangle, and this figure is insufficient to prove this theorem. So that means we have to construct this in this figure. So we construct that, draw perpendicular BD to the hypotenuse. So BD is the perpendicular to the hypotenuse. Okay students, so now next part is that proof. In right angle triangle ABC, segment BD perpendicular hypotenuse AC. So now that means the similarity of right angle triangles. So we can say that triangle ABC similar to triangle ADB similar to triangle BDC. See here students, if you draw the figure, then you understand very well. That is, this is the triangle, right angle triangle ABC. We draw the perpendicular on the hypotenuse. Okay, so that means by the similarity of right angle triangle, these three triangles are similar to each other. Okay, now here take these two triangles, triangle ABC similar to triangle ADB. That's why we can say that the ratios of the corresponding sides are equal. That means AB upon AD is equal to BC upon DB is equal to AC upon AB. Now we choose only these two ratios, first one and the third one. That is AB upon AD, which is equal to AC upon AB. That means by cross multiplication, AB into AB, that is equal to AB square, which is equal to AD into AC, and call it as the first equation, students. Now the second part. Second part, we take out the triangle ABC similar to triangle BDC. Okay, so now here the ratios of the corresponding sides are equal here. So here also AB upon BD is equal to BC upon DC. See here, AB upon BD is equal to BC upon DC is equal to AC upon BC, student. Okay, so that means here we take the second one and the third one ratio. Okay, so BC upon DC is equal to AC upon BC. So BC into BC, that is BC square, which is equal to DC into AC, and call it as the second one equation. Now students, we have the two equation. Now here see, we add these two equation, left hand side to left hand side, right hand side to right hand side. So here AB square plus BC square is equal to AD multiplied AC plus DC multiplied AC. Okay, so now here AC, that is the AC is common. So in the bracket AD plus DC. Now here AD plus DC, that means nothing but the AC, student. So AC into AC, that means AC square. So here AB square plus BC square is equal to AC square. So now by interchanging the side, we have AC square is equal to AB square plus BC square, and that is nothing but to prove. So theorem, Pythagoras theorem is proved. There is a converse of Pythagoras theorem. So statement is, in a triangle, if the square of one side is equal to the sum of the squares of the remaining two sides, then the triangle is a right angle triangle. Now here we have to prove that the given triangle is a right angle triangle. Okay, so here first we draw the right angle triangle ABC, students here. Okay, see here the right angle triangle ABC. Okay, so this one is the ABC right angle triangle ABC. Okay, angle B is equal to 90 degree. So now in triangle ABC we know that the AC square is equal to AB square plus BC square. Okay, now to prove, we have to prove that is the angle ABC is equal to 90 degree, students. So now here this only figure is not insufficient. It's not sufficient to prove this. Okay, so now we have to construct the figure, that is draw triangle PQR such that we have to draw the triangle PQR here. Okay, so such that AB is equal to PQ. Okay, we draw the triangle ABC such that AB is equal to PQ, BC is equal to QR here, and angle PQR is equal to 90 degree, students. Okay, So this is a construction. There are the two triangles, and with comparing these two triangles, we can prove this theorem. Okay. So now see the proof in triangle PQR. We can say that angle Q is equal to 90 degree here, students. Angle Q is equal to 90 degree, and we have PR square plus is equal to PQ square plus QR square as per the Pythagoras theorem, because okay, angle Q is 90 degree. So now PQ square means the AB square, okay, by the construction PQ is equal to AB. So here we write AB square. QR is equal to BC, that by the construction. So we replace this QR by BC. So BC square. So we have AB square plus BC square. But what is the AB square plus BC square? That is nothing but the AC square. So now we have PR square is equal to AC square. Now square root on both the sides. PR is equal to AC and call it as the third equation. So now here in triangle ABC, similar is congruent to triangle PQR, and that is by the SS test. Okay. So now here angle ABC is equal to angle PQR, which is equal to 90 degree. That means angle ABC is a right triangle. ABC is a right angle triangle, students. Students, thank you for watching our videos. Achieve your success with us. I sure that you will get 100% success in maths. So watch our videos continuously, regularly. Like our videos, share our videos to your friends.